Good morning, everyone. Wanted to celebrate writing some grant requests and perhaps getting some funding for my games and do something creative because I was all bound up inside of documentation. And so what I'm showing you here is a little bit of a cheap way or a simple way, maybe a bad way, to do some physics caching in Unreal Engine 5. Now, it's not running as fast as it could because I turned the rendering up to 200%. Let's turn it down to 100 here. There we go. That's a little bit better. But it looks a little bit weird. Here you can see we're 45 frames, but why is it only 45 frames? Because we got the whole freaking matrix happening. You know, we got the AI dealing with these collisions. We got the flip booking going on. We got the cars driving around. Got the whole simulation going on. So, you know, it's hard to kind of do all that and do all this. But let's talk about how we do. So if I hit stop what's going on right now, this is the end result. The end result is that we have 120 ISMs in one actor, this little physics cached actor here. What we did is we're flip booking through them. Here, actually, we got 180 of them. And it's just like a film or a movie. We started off with blank film. And then we had 1,024 actors that we spawned in to simulate physics. We spawned them in up at the top there, and those would be yellow. Right now, you don't see any yellow boxes because they're gone. They're all asleep and been destroyed. But when they spawned in up here. They fell down, they had physics enabled. I don't enable it immediately because I don't want them to collide with each other and deal with all that right up there at the respawn point. But they fell down and started colliding with the environment. The green boxes you see are and you actually watch here, every 60 seconds the loop repeats. Well, actually, the loop repeats, but wherever the boxes fell asleep or stopped moving, a green box is placed, and then we take that mover, put it back at the top, and loop them. We're doing that right here. We're recording for a total of 60 seconds. That means that after 60 seconds, I'll stop teleporting sleeping boxes back to the top. I'll just delete them. So boxes will hang around until they settle, but in general, the simulation is just about 60 seconds for movers. And then, so what you'll see is, we'll go ahead and re-simulate it here. But all these blue boxes are one of 180 in this instance. It's adjustable, which is 3 seconds worth at 60 frames a second that are being replayed, and only one's visible at a time. All the other are invisible. You could, and you probably should, store this information to an array of transforms and then do a batch update on a single ISM instead of storing a whole bunch of ISMs. So I might test that out if I end up using this for something specific. But this is just, I had to do something cool. So let's go ahead and stop it and replay it so we can watch it happen. Then we'll go through the blueprint. So we'll hit play here again. And what I have is a blueprint. It just spawns in the set amount of physics actors. And I also dither it by 100 per second, so that's why it's not just one big bulk. And that's what all these yellow ones are here. So these are real actors that are simulating physics. Once they turn green, that's where the yellow actor has slept and then gets pulled back up to the top of the fountain. The blue are, well, where those yellow actors were historically. It's that film replay. Now right now I have physics disabled on the replay, the blue ones. So the yellow boxes will not interact with the blue boxes, nor will any of the AI. And we'll pause the simulation here just to take a nice deep look before we lose all of our simulation actors. So right here at the top of the fountain, this is our respawn point. The blue boxes, those were respawned before, which were the yellow boxes, recorded themselves into that flipbook as they simulated interactions. What we could do, and I have already built in, is enable collisions on the flip booking ISMs, but it's considerably more impactful on collision simulations because it's doing a lot more work. You're then having, a lot of changing overlap in physics points. So as these yellow boxes go down, they're recording. The blue ones no longer record. That's what was recorded. The yellow boxes will go down and actually simulate physics collisions with the green boxes. So wherever we've slept, those are real, just parts of the world. And then, of course, parts of the world. The blue boxes continue to replay, and they just fall back into the spot where they fell asleep. And let's just actually watch that, because it's kind of meditative. Hit resume play here, fill it up. You can just see every green box, you'll see a blue box will just kind of eventually every 30 seconds or so land there and just settle. The yellow boxes are still interacting. Those are new spawn interactions, new actors that are rather been looped up. And after 30 seconds, I stop looping them. So we're going to see the fountain turn all blue here, and things start. Oh, there we go. It just turned all blue. Now we'll no longer see any yellows being put up there. The yellow active simulators will sort of just fade away as they start to fall asleep in the green. And then we'll have all blue and green ISMs only, which is probably right about now. So we see no longer any more blues. Our performance has gotten a lot better. 45 frames per second is about what you get with physics interactions, just with the AI and cars and all the normal stuff going on in the Matrix. I have the crowd turned up pretty dense, it looks like. So now we have nothing but a physics simulation being replayed. If we go into that actor that has the, and we'll go through all these blueprints here shortly, we'll see what's going on here on tick is we're just one time every 60 seconds, so we have a little tick throttle. Ooh, we haven't finished yet. That's worrisome. Oh, there we go. So we just got the last actor to go asleep and destroyed it. That was simulating physics. Now we're just going through the flip book. That's what I have my little finished toggle here do. And all we're doing is going through here every 60 times a second and changing the visible ISM to the next one in the order of the array. And then we're looping through that. And what that does for us is just hides everything besides one frame. And now we're literally a movie of what was simulated physics-wise. And what we could do as well is this was all done right here while we're recording it. So if you were to move the actor while we were doing it, you could get the simulation to put more pieces other places. If you wanted to, if you put things in place, you know, you can. It's not like this had to happen for an hour in Houdini and then be imported over in Unreal. This happened real time. We just watched it, and it's being replayed. If we were to enable collisions, what you would see that, like right now, these green boxes, which are our sleeping instances, they are interacting with everything, but the blue boxes are not. If you were to turn on collisions on the flip, the one that was visible, that would then make the blue boxes push the AI around and the cars around, or whatever you're doing, which is probably what I'll do for when I record the simulation, is leave the flipbook ISM having collisions so that the yellow actors still collide with it on their way down. And can also, the next step also will be to wake up these green ISM instances, the sleeping ones, when a yellow one collides with it, so that you see some interactions like that moving what's going on, because that would clear off the roof. Because right now you have this roof up here, and all the blue boxes when they simulated and bounced off were yellow boxes, and they could have woken up the sleeping green boxes and pushed them off the roof. And what that would have done is given us that as a replay. We would see these green boxes push off a little blue box, but when it's hit by another blue box, that would then sleep in that spot. So we would get all that interaction just by waking stuff up during the recording phase, and it would cost us nothing during the replay phase, which is right now. You're seeing some blurriness. That has a lot to do with lumen. These are emissive materials, so if I was to turn off lighting, they are all emissive, so that leaves a little extra shadow. Also, with that much motion, it's just kind of hard. So play with your own settings. So it's not really anything with the replay. It has to do with the type of rendering I'm using right now, and ray tracing and stuff like that. Which you can see all this in the replay in the windows, which is pretty cool. All right, let's look at the blueprint. Stop the simulation or the replay. and open up this blueprint. Now, I know I'm working in 4K. Hopefully you can see some of what's going on here. I tried to clean up the code and put some comments. Alright, so it's very simple. 2 blueprints, the simulating actor and also this manager. And that I call the recorder and the recording manager. Alright, here on the recording manager, the first thing we do is spawn the flipbooks that we need. So I have a flipbook count I set, and I spawn those in. This will just be our individual frames of the film. And I add them to an array down here, this ISM array. Why is this thing being funky? Turn off real-time rendering here, maybe that will help. Let's just walk through every node. So we do a loop. We add an instance static mesh component to this actor. We go ahead and set it as the active frame ISM. We do that because at the end, once we've added them all, we'll still have one frame to use to add. I should probably go ahead and make that the first one in the chain, but so this is definitely a work in progress. We set a material on here so that you can see that's that blue material that the ISMs have. We go ahead and make sure we're not generating overlaps, and we turn off collisions. This is what the invisible version of the ISMs have, is no collisions. So this is that default invisible state. We take and make the object type world dynamic. This helps to clean up the anti-aliasing issues you were seeing. We add it into the flipbook array. We go ahead and set the static mesh so we can go ahead and change that on the fly with the script. And we set it to invisible. And then after that, we'll go ahead and spawn another ISM. This is the sleeping ISM. This is where the green boxes are. We set the material for green to it. We enable collisions so that you can go ahead and collide with the sleeping ISM. We set the static mesh to whatever our static mesh is, and turn off generating overlaps just because I didn't need them. Set to what your needs are for your environment. And then also at the end, we'll go ahead and loop through and spawn our actors. So we'll go ahead and have we'll check and see if we have any actors to spawn, or that have been spawned, and if we do, we'll see if that count is less than the total count we want to have spawned. So that's another variable. So I said, the variable is for how many we want to spawn. So we'll spawn in that many actors, and we'll use a delay node here since we're doing this off begin play, so that we only spawn them in once every 1/10 of a second. After that delay, it will go ahead and see if we're over that limit, and if so, stop the loop. We'll go ahead and spawn them at wherever the spawn point is. So we do have a spawn point on the actor here that will get the roar location, and this is where we'll initially spawn the actors at. We'll spawn the physics cached actor. That physics cached actor, we'll look at that really quick. What it is nothing more than an actor with a static mesh on it. I call a recorder. The viewport here has a square right now. It can be changed. It's that yellow color. I put it on here, so that's when you see the yellow actor, the bright actor. That's the first one. And it has one event on here, which is on begin play. It will disable its collisions for between half a second to a second. And this is so to blend when it's enabled, so they don't all wake up at the same time and bounce off each other. And also, we do this. We trigger this, which disables its collisions and re-enables them after that time period. Whenever we teleport it back up to the top of the fountain. And so this is just preventing collisions on the recorder or the simulating actor itself. So we'll spawn a bunch of those in that are immediately simulating, and we did that spawn at the top. So that's when we get the initial recorders. We save those to a list, so we always have them, and we'll use that later. Set the static mesh, and also set a random velocity so we can get a little bit of coning up there so they're not all bunched together. Which helps with the replay, because if you want to think of it as a loop, like an animation or a GIF or anything that you want to have looping. Water flow is a great way to think about simulations like this. Essentially, what we're showing is a repeated event, not something that just happens once. You could have it just happen once, then just basically just record where the things are, rather than send them back up to the top, and then replay that wherever you want, and that's how you record it once and do a replay of a one-time event. So down on tick, this is what happens every frame that the computer processes. We'll come in here and we're going to limit how often we tick or how often we process to just do it once every 60th of a second, so we get 60 frames a second. That was just my decision. So we set up a game time limiter on that. So we take game time seconds. This is what the current running time is in your game. We add our next flip time. We check if it's greater than our next flip time. That's our next time to run. So if it is, so initially that's 0, we'll go ahead and set our next time to run, our next flip time, to be 1/60th of a second from now, plus the game time. We'll come over here. Finish is saying that, hey, have we done all the recording? If we've done all the recording, we have a quicker way to do the flip book where we don't have to do all that recording stuff. So if we're finished, we'll talk about that because it's here. So if we've already recorded all the locations and all we're doing is replaying them, we take the active ISM that's shown and hide it, make it invisible. We go ahead and advance the index to the next frame, which is just a running variable, by adding 1 to it. If it's larger than the frame count, which is how many ISMs we have in our film, we go ahead and reset it to the first one. So this is where we reset our loop of our film. And we set the active frame to be our last frame so that we know when we add things, we want to add it to the last frame so it doesn't collide with us. But that's more of a thing below. So maybe I can skip this right here, actually, because we never use this stuff again. Thinking, processing. Yeah, I think I can skip that. Boop. So you can skip setting this, but we'll need it right below it, right here. Let's do that so you know I mean it. Then we get this frames ISM. So what we get here is the current one that we have, the active one. This is the one we're going to want to make visible. And we make it visible. If we are not finished, this means we're still recording, then we're going to come down here and make the active ISM visible. We're going to turn off collisions on it if we, enabled collisions. So I still have that in here as able to be disabled. This would allow the following ISM if we then, you'll see here right in a second. We grab the spawn point, so wherever we're going to respawn stuff to, and store as a variable because we're going to do that a lot when we check the different actors. We advance the index by 1. We see if that index is over our frame count. Again, if it is, we reset it. This is where we're looping. We set last active to the current active ISM, and then we're going to advance that one. So this is where we get our last frame so that we can go ahead and add to it our location so we don't collide with ourselves, meaning so that our yellow simulating actor doesn't collide with the location. It's just recording. If we have the ISM have collisions enabled, where it would. And then you'll get like some life AI type of, I should do it just for the video. You'll get some AI type of interactions because the simulation will collide with itself and push itself around, and you'll get that recorded. It's fun. Anyway, sorry for the side post there. What we're doing on the bottom part, if we haven't finished when we're recording still, we're setting the prior ISM that you could see in the prior frame to invisible, and we're setting that to the last active ISM. And then whenever we're going to record all the locations for the simulating actors to that last ISM so that they're not visible, because we don't need them visible until we loop that all the way back around in the replay. So that's what we have a last ISMs, because that's what we're adding stuff to. We get the active ISM, so we have it, we make it visible, because it's really the next frame we want to see. And then we enable collisions on it if they are enabled. So this is where if we set it to enable collisions on the replay instances, we could collide with actors on them. That's very impactful on runtime, but it's something you'd want to do if you were just replaying this for a pre-baked replay, like a destruction event. We check if the recorders are empty. The recorders are all our simulating actors. If that's true, then we can go ahead and make all of our ISMs no longer have collisions, because we're just going to go to raw replay. And you could change this if you wanted to have your ISMs always have collisions, or the replay to always have collisions. But then you would do the lower part here and enable and disable them instead of skipping that, which is what the top does. So the top part, once we finished, we're doing our flipbook, it's going to skip enabling and disabling collisions and just leave collisions disabled because we're just showing that interaction. If you wanted to, you could enable and disable collisions for each visible ISM, so that then the world would have to deal with those replay instances. But it costs a lot more because you're calculating all that physics for all the actors and things in the world. If you are still recording, you'll go to the lower path here if the recorders are not empty. And what we're going to do is we're going to check all those simulating actors or recorders to see if they are still moving fast enough or if they should be put to sleep. So I'm doing my own sleeping. So we loop through all of them. So we're doing a loop of 1,000 right here. So that's pretty bad in blueprints, but easy in C++ or Sharp. My sleep check is I'm just checking velocity. If our absolute max velocity, and I say absolute max velocity of any one here. So we got a recorder, we get the root, we get the component velocities of the root, we get our absolute max velocity. This means that if we're falling straight down, we could have a negative 1,000 velocity. This makes it 1,000. That way we can always check if it's larger than 10. And 10 or some value here would be where you would put it to sleep. So this is like if the fastest this thing's going is slower than 10 in any direction, we're going to go ahead and make it fall asleep. And if we make it fall asleep, that's the lower path here. What that will do is it will take and, the upper path must be falling asleep. Returns if less than. Yeah, so the upper path is falling asleep. I was trying to color code these. I'll change them to green and blue. Alright, so if we're going slow enough, if the physics actor is going slow enough to fall asleep, we'll go up to the top path. We'll store the location into an array of transforms to add because it's faster to add in a bulk array. So we're basically saying, hey, this one needs to fall asleep to a sleeping ISM. Here's the array of the ones that are going to do that this frame. Let's add it in there. Then we're going to go over here and stop sim after period. Get game time till recorder delete. If it's greater than this, add to that. Okay, what we're doing here is I have this variable for how long we're going to record, how long we're going to cycle our actors before we start deleting them. So if it's been long enough, we've recorded enough past that time period, we go ahead and add that actor to be deleted. If it hasn't been that long, we're going to go ahead and respawn it or loop it back up to the spawn point. Let's see, how long is this? 23 minutes. Well, if you're watching, let's go. We'll loop it back to the spawn point. We trigger collisions on that actor. It's going to go ahead and disable collisions and then re-enable it up to a second later so they don't interact with each other at the spawn point and get stuck. We'll move it up to that location and we'll go ahead and give it some velocity to sprout out, just like we did before when we spawned it in. That way, and it's the same values. Actually, it might be a little bit more aggressive here. You want to try and match them because you want that looping action to be about equal. So here, this is what it took to match. If that recorder is going too slow, rather than then we'll go ahead or rather going fast enough to not be slept, then we'll go ahead and record it into the flipbook, blue flipbook ISM, into the last ISM that was rendered, that last active. To do that, we'll come down here, we'll check and see if it's out of bounds, of course. That's a good thing to do. If it's out of bounds, we'll go ahead and delete it because it's just, why not? Or you could loop it back, but I was just doing deletes because if they get pushed out of bounds, I guess I should loop this back. You should loop this back in. You shouldn't delete them. I'm just deleting them if they go out of bounds. If you loop them back in, you get more of that recording of the data. And then if they are at the end of the loop, and then we add the transforms if they are not out of bounds and they're going fast enough, we add them into this add last frames. We get done checking all of those recorders and finding out if they're out of bounds, finding out if they're moving slow enough to be slept, finding out if they're just moving fast enough to be added to the last frames ISM. add them all to arrays to cover that. Then we come down here and we actually add them into the ISMs as a bulk add instances. So last active ISM, add that bulk all those transforms for the moving fast enough recorders or simulators. Then go ahead and clear that array out. Sleeping ISMs. Go ahead and grab all the ones that were asleep, moving slow enough, and add them in right now as a bulk. And this frames add-ins, clear those out too. Clear it out once you add them. And then at the very end, once we're done with all the loops, once we've done all that stuff, go ahead and take the actors that are made to the list that need to be deleted. This could be because we are over our time period of recording or because they fell out of bounds apparently. And go ahead and remove them all from the recorders that are list, and then destroy those actors, and then clear the list of them. And that's how we do it. So, boom, boom. And now let's go ahead and hit play and watch it happen. And now you can go ahead and we'll watch them all get spawned in here. So it's spawning in so right now we're going to spawn 180 instances, which is 3 seconds worth of loop. And you can see and 1,024 actors. You can see the boxes there. They're coming out, and when they turn green, they're going to be looped back up to the top of the fountain. And now we got blue ones coming out. Blue ones are that yellow one that just happened, that was recorded, put in the flip book. The blue ones are. So let's walk it through. Yellows are spawned in. Those are the actual simulators. They simulate, they record. Blue is where those records are being replayed. Then the yellows are turned to green when they fall asleep on the ground or wherever they fall asleep, moving slow enough. Those yellows then are recycled back up to the top of the fountain and allowed to resimulate. Since I have collisions disabled on the replay of the simulations, the blue ISMs, the yellows do not collide with them, but they will collide with the green ISMs that have collisions, and of course the environment to create new interactions. Now we've stopped replaying or recycling because we've hit the end of how much we want to simulate. So we've stopped moving the yellow actors when they turn green, like that one turned green, back up to the top of the fountain, and instead we're just replaying the ISMs in a loop and what they did. And so what's happening right here now is we're just getting what's 180 instances or ISMs, and all the recordings, all the data in those ISMs is being shown as they're being unhidden, made visible for 1/60th of a frame of a second, and flipbook through. So if we come in here and look at this whole thing, it's going to look like one actor that has a bunch of ISMs on it. Now let's see, what else could I show you on here? We can go ahead and hit nanite just to be funny. Triangles. Look, it's all nanite, and you can see it's simulating. And also the green ones, the green sleeping ISMs where the boxes come to rest, those will interact with the AI because we left the collision on. So they'll block the path, they'll crush the cars, stuff like that. If you enable collisions on the simulating, or the replay ISMs, the blue ones, then that will go ahead and collide with and do deformation on the cars too. But it's just if you want to have that impact or if you want to have a visual. So I mean, this could be water. I mean, this is how you simulate water and replay it, only without doing so in Houdini or externally. This is done directly in Unreal. And how this would be water is that you turn these into spheres and you deal with the rendering of how they bounce into each other and all that good stuff to make it. This is how you do water. It's just how they're bubbling and interacting with each other. So this is, and yeah, so thanks for watching. Thanks for checking this out. I'm gamedev Micah on the X platform, Twitter. Hey, you know what? That's how it sounds. I'm a Die Pepsi on ye old Reddit. And yeah, Micah Berninghausen on LinkedIn. Cheers.